Hello there, class. Welcome to another video lesson for the second quarter of grade 10 mathematics. Our topic for today is about solving problems on circles. Remember, this is still from version 5. Are you ready? The objectives. At the end of this session, you learners would be able to solve problems that involve chords, arcs, central angles, and inscribed angles on a circle, and solve problems that involves tangent and secant of a circle. Let us have a little review. Now, I want you to remember this always, definition 1, because this is very useful in solving problems on circles. The degree measure of the minor arc is equal to the degree measure of its central angle. Look at the figure on the right now. Now, we can see there an arc BC intercepted by a central angle BOC. Now, if BOC measures theta, or the theta represent the measures of the central angle BOC, whatever the measure of theta is also the degree measure of our arc BC. Get it? Another review, Theorem 1. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Look at this circle A with diameter MC and diameter HP. Now, the central angle PAC has a measure of theta 1. Also, the central angle MAH has a measure of theta 2. And the corresponding arcs or intercepted arcs, PC and MH. Now, if the measures of central angles PAC and MAH are congruent, then the arcs CP and HM are also congruent. That's what the theorem is talking about. Theorem 2. The degree measure of the inscribed angle is 1/2 the measure of its intercepted arc. Let's take a look at circle B, having a diameter CA and a chord CD. Clearly, we can see an inscribed angle DCA there. So, the inscribed angle DCA is intercepting the arc DA with measure 80 degrees. Now, if our inscribed angle DCA has a measure of alpha, how do we know the alpha using theorem 2? Then we can solve it actually through this. Our alpha, or the measure of angle ACD, is equal to 1/2 the measure of arc AD by the theorem. Or simply substitute 80 degrees to arc AD, so 1/2 of 80 degrees, our alpha is equal to 40 degrees, or the measure of our inscribed angle DCA is equal to 40 degrees. This is very useful in the application. Okay, so by looking at the figure, circle O there has diameters CF and AE. Now we can find the number of central angles. So definition 1 is very useful in this case. Now, we have 3 statements here that we are going to evaluate whether it is true or false. Statement 1, the measure of angle COD, that is a central angle, is 45 degrees. Number 2, arc BCD measures 105 degrees. And number 3, the measure of angle COD is equal to the measure of arc ABC. Now, can you answer? Which of these statements are true and which is false, or which are false? Okay, to help you, let us solve number 1. Number 1, the measure of angle COD is 45 degrees. Take note that in the figure, the central angle COA is having a perpendicular symbol. That's the little square there. It means that the measure of that angle is 90 degrees. And since CO is perpendicular to AE, a diameter, then the measure of angle COE is also 90 degrees. Now, the intercepted arc of angle COE, there is the arc CDE, which is also 90 degrees. So we can solve angle COD using the arc CD with this equation. Okay? So 90 degrees because CDE is 90 degrees, or the angle COE is also 90 degrees, minus the given there 30 degrees for the DE. So the answer is 60 degrees. In other words, our angle COD is also 60 degrees, which means the statement is false. Number 2, arc BCD measures 105 degrees. By looking at the figure, we have solved earlier for number 1 the measure of the arc CD. And now, by looking at the figure, BCD is simply, okay, so arc BC plus arc CD, which is 105 degrees. Which means our statement number 2 is very true. Okay, let's proceed now to our statement number 3. The measure of angle COD is equal to the measure of arc ABC. By looking at the figure, arc ABC measures 90 degrees because it is intercepted by angle COA. But we solved the arc CD earlier for number 1, which is 60 degrees. Which means our statement number 3 is false. Very good. Another activity. Looking at the figure there, we have BD as diameter, and then, okay, the inscribed angle DBC measures 40 degrees, or angle CBD. And an arc AB measures 95 degrees. The statements, okay, let's evaluate the following statements whether they are true or false. Number 4, arc CEB measures 100 degrees. Okay. Number 5, central angle DOC measures 40 degrees. And number 6, the measure of arc DEB is twice the measure of angle A. Okay, let's answer number 4. We are going to solve whether the measure of the arc CEB there is 100 degrees. How do we do that? Okay, take note that we have there BD, which is a diameter. And since it is a diameter, then this DC, arc DC, and arc CEB makes a semicircle. The BCD is a semicircle. And take note that arc DC is intercepted by our inscribed angle DBC, which measures 40 degrees. So we can solve. Okay, so arc DC there using theorem 2. Okay, this time using theorem 2, that the measure of the intercepted arc is twice the measure of its inscribed angle. So since inscribed angle is 40 degrees, 2 times 40 degrees is 80 degrees. Now we can solve for the measure of the arc CEB. So it's just equal to the whole semicircle BCD minus the arc DC, which is 80 degrees. So it's simply like this, 180 minus 80 degrees. And arc CB is really 100 degrees. So the statement number 4 is true. Correct. Number 5. Central angle DOC measures 40 degrees. So by looking at the figure, DOC there intercepts our arc DC, which we solve as 80 degrees earlier. So using definition 1, the measure of the central angle is equal to the measure of its intercepted arc. So the intercepted arc earlier is 80 degrees. Then our statement number 5, okay, is false because of the solution there. Now, number 6, the measure of arc DEB is twice the measure of angle A. So take note that this is our arc DEB or BCD or DCB. Okay, that is a semicircle, and a semicircle is an arc intercepted by angle BAD or angle A. So by theorem 2, our statement number 6 is true. Good job. Now, For on tangents and seconds, now we have Theorem 3. If two seconds, a secant and a tangent, or two tangents intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arcs. Now we have three situations there. 2 seconds, a secant and a tangent, or two tangents. Okay, so let us have the 2 seconds. Okay, the 2 seconds first. So as you can see there, we have an angle DEM or REA on the outside of the circle, and we have arcs AR and DM. Okay, so the angle DEM, which is outside the circle, is equal to 1/2 times the positive difference is the measure of arc DM minus the measure of arc RA. So their angle measure. So that is what is meant by 2 seconds. Now a secant and a tangent. Here, the same theorem, and we have there a secant and a tangent. So there we have an angle FRT, as you can see there, outside the circle. So we have intercepted arcs OT and FT. So to solve for the measure of the angle, it's 1/2 the positive difference, so FT minus TO. I mean arc FT minus arc TO. Okay, to continue with our Theorem 3, the third situation, we have there a circle, a tangent, another tangent. So we have this. To solve for the measure of our angle OUT is equal to 1/2 times the positive difference of arc OBT, the bigger arc, minus the arc TO. Okay, so I have presented you the three situation for our Theorem 3. Now, let's proceed to Theorem 4. If 2 seconds intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So let us have a circle there. We have the first secant, then the second secant. Yeah, like for example, AGL, then it is 1/2 times, okay, the sum of the intercepted arc and its vertical angle. So the intercepted arcs are AL and IN. So that's how we solve it. Or another angle LGI. So to solve for the measure of the angle LGI, it's equal to 1/2 times the intercepted arcs LI plus AN, arc AN. Okay? For Theorem 5, if a tangent and a secant intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So just like this, we have there a tangent LS and a secant NG. To solve for the measure of the angle GNS, then it is equal to 1/2 times the intercepted arc GIN. Or for the angle GNL, it is equal to 1/2 times the measure of the intercepted arc GAN. I hope that's clear with you. Okay, so another. Theorem 6. If two chords intersect, then the product of the measures of the segments of one chord is equal to the product of the measures of the segments of the other chord. Just like this in the figure, we have one chord, then the second chord. So the FE and the OX. For the segments of the intersecting chords there, say we have FR times ER, that is for chord FE, is equal to the product of OR times XR for chord OX. Okay? And then, Theorem 7, if two secant segments are drawn to a circle from the exterior point, then the product of the lengths of one second segment and its external segment is equal to the product of the lengths of the other second segment and its external second segment. And now for the illustration, look at the circle. We have here a second and another second. So a second PS and a second PR there. By looking at the figure, we have there the length of segment PU times the length of segment PU plus US, or the whole of PS there is equal to PE, the measure of PE times the whole of PR, which is PE plus ER. Okay, so that is how we solve. So another representation is PU times the whole of PS is equal to PE times the whole of PR. Okay, so that's what I'm talking about. So are you ready to make use of the discussed theorems to an application? Okay, so let's consider this figure. We have there 2 seconds intersecting at A, and we have one measure of intercepted arc, which is 20 degrees, and another measure of an intercepted arc 100 degrees for arc DE. Okay, now let us validate each statement if it is true or false. So first statement, the measure of angle A, which is the angle outside the circle, is 1/2 the sum of the measures of arc BC and arc DE. So 1/2 the sum of the measures of arc BC and arc DE. So remembering a theorem, the angle is on the external of the circle. So I think the word sum there is what makes the statement false. Okay? It's supposed to be the positive difference. Okay. Now, number 2. The measure of angle A is 40 degrees. So, of course, in this case, we need to solve for angle A. Okay, so angle A is equal to the 1/2 of the positive difference of the arcs DE minus BC. Okay, so arc DE is 100 degrees minus 20 degrees. Then 1/2 of 80 degrees is 40 degrees. So it's true. I did not write the 40 degrees there because I know you know how to solve it. Statement number 3. The measure of angle DEB is 115 degrees. By using a new figure there, we have seconds that intersect in the interior of the circle. So given, we have arc AD 50 degrees and arc CB 80 degrees. Now the question, is the measure of angle DEB 115 degrees? How do we solve that? Okay, to solve for this angle DEB, first we need to solve an angle using the given. So let's try to solve angle AED, because when we solve angle AED, then we can make use of the 80 degrees and 50 degrees. So solving for the angle AED is equal to 1/2 the sum, okay, of the intercepted arcs 80 degrees and 50 degrees. So it's 130 degrees. 1/2 of that is 65 degrees. Now we have solved angle AED. Take note that angle AEB is a straight angle, meaning to say 180 degrees. So we can solve now angle DEB because we have solved angle AED as 65 degrees. So to solve for the angle DEB, we have 180 degrees minus angle AEB, which is 65 degrees, and the answer is 115 degrees. The statement is absolutely true. Chems. Now, by using again this figure to solve for, to identify whether the statement number 4 is a true or a false statement. So angle CEB measures 65 degrees. Okay, so let us make a simple recall there. Angle AED and angle CEB are vertical angles. And in our grade 8, di ba, using the parallel lines and transversal, vertical angles are equal. So our statement means true. Correct. Number 5. The same figure, angle AED and angle CEB are congruent. So it's just the same with statement number 4. So is this a false or a true statement? Again, angle AED and angle CEB are angles with equal measures. So by definition of congruent, therefore angle AED is congruent to angle CEB. Okay, by definition of congruence, the statement is true. For more exercises, class, please refer to your module. Okay, the one that I gave you or we teachers gave you. I hope you learned something new today, which you can use in solving the problems in your modules. And for questions and inquiries, don't hesitate to write your comment in the comment section. Thank you very much for being with me today. God bless you all. I am teacher Anthony G. Arisgado, grade 10 mathematics teacher of Bukidnon National High School. Good job! Math is fun and math is really for everyone. Bye-bye.